Section views from 3D laser scan models. In short, SCAN3D. Growth of 3D laser scanning and modeling industry in the last 20 years has led to the need for different strategies to analyze, create, and process 3D models. The Zamani Project requires a tool for the creation of layouts/diagrams of sections, elevations, top views, and ground plans, and other generic views from 3D laser scanned models of heritage sites. Two sub-projects tackle feature line extraction and 3D slicing for the models.
Feature line extraction. To extract feature lines, we're going to use a fan disk model. The fan disk model is shown. We're going to rotate it so that we can visualize what it looks like. After visualizing the model, we close it. Then we run the tensor voting algorithm. The tensor voting algorithm selects feature vertices from the model. The results from the model are shown as you can see. The results from the model show noisy vertices. In order to remove those vertices, we run the salient measure. We're going to put a salient measure of 0.3, as we can see from the graph. That allows us to select the points we require. The salient measure filters the noisy vertices from the model. As shown, we can see the noisy vertices are normal on the selected feature vertices. Shown are the results from the salient measure. After running the salient measure, if we're satisfied with the results, we enter yes, we enter Y for yes, and we move on to the neighbor supporting algorithm. The neighbor supporting algorithm connects the feature vertices and forms feature line. This part of the algorithm is time consuming, so we'll fast forward a bit till we get the results from the neighbor supporting algorithm. After running the algorithm, the neighbor supporting algorithm, the results are shown. The neighbor supporting algorithm just connects the lines and generates the feature lines as shown. For this iteration, the algorithm takes 417 seconds, and that is it for feature line extraction.
(3D slicing). 3D slicing uses the concept of clipping planes, which removes parts of the model that are not needed to be rendered. Using MeshLab, the model is being rotated to show the outsides of the model, and also the borders and fencing of the model have been removed. A simple GUI was constructed to handle the loading of the model, and it is being run right now. The model is being selected and the processing starts. As a new window is appearing, the first image is a floor plan of the model, which shows the insides or the internal structure of the model. And this was done using clipping planes to remove the top parts of the model that are not required. For this iteration, the runtime to produce a ground plan took about 77 seconds. As the new image appears, this image shows the top view of the model, which did not require any slicing through the model. So it's just an outside view of the model. As the new image is being displayed, this is the first of 4 elevations of the model. To produce these elevations, it took around 338 seconds. The following image displays one of the section views of the model. In this case, it required using clipping planes to remove parts of the model. It took around 116 seconds to produce the section views for this model. And finally, this is the ground plan with its included section views, elevation lines, and scale. And that's it for 3D slicing.